Okay, everybody, there's a whole load of writing here for people who like writing. I would probably just watch the video and pause it on this page. That way you can write it all yourself later. And some of you don't need to write it at all because everything that's here, I'm going to do lots of examples so you can kind of see the gist of it. But essentially, we're going to be doing two things today. I got the pages, well, not Mars, back to front. We're going to be doing critical numbers, and we're going to be using critical numbers and other things to find the absolute max and min of a function in a given interval from A to B. These values of x, A to B, are called the endpoints. So you'll hear me saying endpoints a lot. I'm talking about these two numbers. Well, let's look at critical numbers then. Critical numbers of a function are y equals f of x, are the values of x where the derivative of the function is 0 or the derivative is undefined. So we did that. We talked about that a little bit and did some examples yesterday. So critical numbers are places, x coordinates, where the derivative is 0 or undefined. And here's a little baby one just to get you into the swing of things. Suppose you had this quadratic and you wanted to find its critical numbers. You differentiate it. And then you solve for when is it 0. In this case, it's 2. So x equals 2 is a critical number. And you have to remember a critical number is the x coordinate, not what the y coordinate is, we don't really care, but the x coordinate. So the x coordinate is 2 is a critical number. And then we've got some stuff over here that I'll bring back to you later so you can get another chance to write it. If you haven't started it, that's fine. And let's just focus on finding critical numbers. Let's just get used to that process. So where shall I go? Well, let's do a cubic. So I have 2x cubed plus x squared plus 2x. And I would like to know its critical numbers. In this case, would you agree that the only critical numbers that are going to exist are when this derivative is 0? Would you agree this function is never going to have undefined derivatives, right? It's just a normal curve. So, power rule. Now, when you do derivatives, you do style points. Style points, right? Make it look like the original and factor the heck out of it. That's going to be our main go-to guys. Look at that guy. Can you factor it in any way? Even if it's a little bit, it's worth doing. Can you see anything that you can do here as a factor?
2.
Okay. Say it again.
2's out.
No, oh God, my hearing's going. What did you say, Skylar?
You can factor 2 out.
Yeah, factor the 2 out. So that gets me 3x squared plus x plus 1. Now, I hope that you've not lost your factoring ability. Why am I doing that? Oh, I know what I'm doing. Can you factor this guy? Let's phrase it that way. Can you factor it? No. If you can't factor it, what's your next plan of attack? Because that's finished, right? So now you have to solve when is the derivative 0, which means we are trying to solve when that guy is 0. And since this doesn't factor, how am I going to find the critical numbers? Math
Ready?
99. Say again?
Quadratic.
Is a quadratic formula. Yeah.
Yeah.
There were three ways that you solve quadratic equations. The one you want to do is factor it, because if you can factor it, it's like 30 seconds, it's done. When that fails, you're pretty much screwed, because you then have to use a quadratic formula. And that quadratic formula is never pretty and is ugly and it takes forever and a day, but that's what it is, so that's what you got to do. So in the quadratic formula world, don't I only need to solve that guy? The 2 doesn't matter. And A is 3, B is 1, and C is 1. And this is definitely going to test the old cobwebs. What is the quadratic formula?
Negative b plus or minus the square root of b squared over... I don't remember. I got the first part.
Yeah, you good start.
Or AC.
Got the first part. Yeah, good.
Over
And
2a.
over what? What goes in the 2a? Give me a chance to do one of my repeated comments. Nothing in math ever goes away. You might have thought, oh God, I'm glad factoring's finished with. I hated factoring. I wasn't good at it. I've done that class. It's finished. No, factoring comes back. You might have thought, well, I'll never need to use that quadratic formula again, at least. Come on, that's never going to happen again. Yeah, bad news. Yep. Everything you've ever done in Math 94 onwards, anything that you've done from Math 94 onwards will appear now and again. It'll appear for one question and you won't see it for 6 months. Or it'll appear in 10 questions in a row, but it'll appear. So this fella is -1 plus or minus the square root of 1 squared, take away 4 times 1, or A, also 4 times 3 times 1. And the whole thing's going to be over 2 times 3. And I'm really annoyed at WebAssign. You're about to see why. See, after doing all that hard work, what does that square root of -11 tell me?
Doesn't exist.
Yeah. So that is just unsatisfying. Now, I'm going to pick one that has a solution. I guess does not exist is going to harm. There are going to be some functions that have no critical numbers. You know, e to the x has no critical numbers. Would you agree if you differentiate e to the x is never 0? So I'm making harm. Right, let's pick one that does work. How about g of a equals v cubed, take away 48v plus 7. Right, I can see some solutions to this one. I should have probably looked at solutions in the other one. Power rule. Okay. Let's make this one look pretty. Come on, let's factor this guy.
Yeah, factor out to 3.
You agree? Can you see anything nice about v squared minus 16?
It's a difference of 2 squares.
So set it to 0. V equals -4 is a critical number and v equals +4 is a critical number. Right, that's the way quadratics should go, shouldn't they? They should be nice and they factor well and the answers come out, and I don't need to do quadratic formulas or anything particularly ugly like that, and that is good. So let's pick a different function. This one's like number 9. Let's just do critical numbers. That's 1. Oh, almost forgot. If you want to differentiate the cube root, won't you have to call it t to the power of a third? So differentiate that, you get 1. Differentiate this, you get 1/3 t to the negative 2/3. Okay, make this look pretty. You factor the heck out of it and you make it look like the original. There is the derivative. Right? Couldn't really factor anything, right? But couldn't at least make it look like the original. Okay, so let's get its critical numbers. Looking at this function, I can find when it's 0. So I'm going to be solving that guy, and the working's going to go here. Looking at this function, is there any value of t where this function is going to be undefined? Because there is, isn't there?
0.
0. So we know already, can I just put t equals 0 here, right? That's a critical number because this is undefined. So let's go back to finding when is the derivative 0, because that's the other place where critical numbers live. And you got to figure out, and you got to adapt to whatever ugly equation you're trying to solve. 1 take away 1 over the thingy, there's a square missing, right? 3 cube root of t squared. And we've got to solve that. And we're going to try and get an exact value. If I just wanted a decimal, couldn't I plug that into decimals and find out where it crosses x-axis? And I get the answer 1.2345 or whatever. But we're trying to get exact values. So that makes it much harder. As long as you do it to both sides, it's okay roll. So I would do this. So give me something to do to both sides.
Add 1 over 3 cube root t squared. Just add that
Okay,
to both sides.
that sounds like a good plan. Yeah, add that to both sides. Agree. That's a good start. If I call this 1 over 1, I may give you an idea of what I'm going to do next.
Would you cross multiply?
Okay. Or you could say multiply both sides by 3 cube root of t squared, right? But it is cross multiply as well. So what do you get? You get this guy equals 1. Now, some people can go straight to there. How could you go from this line to that line? What would the logic behind it be? Well, wouldn't this have to equal 1 if it was going to be 0? Right. Okay, a lot to do yet, but at least it's getting closer. What should I do to both sides now?
Divide by 3.
Okay. What should I do to both sides now?
Cube.
And if you cube a cube root, you'll get t squared. And if you cube this guy, can we just call him 1/27th? Okay, almost done. What do you get for this guy?
Would it be plus or minus square root of 1 over 27?
Yeah. And you would probably want to make it look a little bit prettier. And if you want to be a purist, although I don't think it's really necessary, you could make it that. So there's actually a negative 1 over the square root of 27, and there is a positive 1 over square root of 27. So there were, in fact, 1, 2, 3 critical numbers in this particular question. So you differentiate it, you do your style points, right? Factor the heck out of it and or make it look like the original. And then you can go looking for the critical numbers. When is it 0 and when is it undefined? Try this fella. Okay, I'm just looking for critical numbers. Look at that guy. What process am I going to use to differentiate this fella?
Quotient rule.
Agreed. So f dash g, take away f of g dashed over g squared. It's going to be f, it's going to be g. Let's put some brackets around them. Right, differentiate the top, you get 1. Leave the bottom alone. Take away, leave the top alone, and differentiate the bottom. And the whole thing is going to be over that guy squared. Okay, we need to do style points. 1 times that guy is just y squared, take away 3y plus 9. What on earth am I going to do about this fella? I can't just leave him alone even if I wanted to. I got to do stuff. What am I going to do?
Foil.
Yeah, so I'm going to foil it and then remember to subtract. So y times that is 2y squared and then subtract it. Y times that is negative 3y, then subtract it. Y times that is negative 6y, but then subtract it. Negative 3 times negative 3 is 9, but then you subtract it. Well, actually, a lot of quite nice things have happened. Won't that 9 get killed off by that 9? Won't that negative 3y be killed off by that plus 3y? Won't that partially kill off this guy? And what we're left with is a 6y take away a y squared. Well, it's looking nicer. You know, you keep going till you can't do anything else. Can you do anything to the top line? Even if it's a little, you should do it.
Factor out a y.
Now, if you factor out a y, would you agree that style point's over with? Can't do any more. Now, when is it 0? When is it undefined, right? That's going to be my critical numbers. I can do them pretty much looking at it. Would you agree y equals 0 is a critical number? Y equals 6 is a critical number. Is there any time where this is undefined? Well, that happens if the bottom is 0. Can you trust me that that bottom doesn't factor and it's never going to be 0? So if I did the quadratic formula, it wouldn't work. I'd probably put it into Desmos and you see a big happy face, you know, x-axis, and it's up here. It never cuts it. So bottom line is 2 critical numbers and we are done. Right. So we've had practice here at finding critical numbers. So let's put the package together and do this fella. How do you find the absolute max and minimum of a function y equals f of x? in some given interval, because they will give you an interval a to b. And the one I'm doing is x cubed minus 9x squared plus 7, and it's the interval negative 4 to 8. And here are the steps that you typically will take in every one of these questions. Step 1, differentiate the function. And that includes style points. Step 2, find all the critical numbers. Well, we've done lots of practice at that today. A little different, but only a little. Only use numbers in the range A to B. So if you get a critical number like 5, it's okay. But if you have a critical number and it's 10, if it's outside this range and you have a critical number that's outside this range, you ignore it, right? You say, I can't use it, you're not in the interval, right? So you only use critical numbers in that range. So that's what step 2 is about. Step 3, you evaluate the original function, right? This guy, not its derivative, but this guy, and you evaluate it at the endpoints, negative 4 and 8, and at any critical numbers. And the one that's the biggest y value is your absolute max, and the one of those guys that's the smallest y value is your absolute min. So here's our question. I'll take you through the steps then. We are going to find the absolute max and min of this cubic in the interval negative 4 to 8. So step 1 is differentiate. So 3x squared, take away 18x plus 0. Let's do some style points. Is there any factoring you can do to that guy? Even a little is better than nothing.
3x.
In fact, isn't that pretty much as good as it can be? So step 1, differentiate. Done. Step 2, get the critical numbers. Well, if I want to find when is the derivative 0, in this case, I'm just solving that. And x equals 0 and x equals 6. Now see how easy it was because we'd done the style points? Now, I should do a double check. Are those two numbers in this interval? Can I use them? 0, yep. 6, yep. We're good. Step 3, evaluate the function at the endpoints, that's essentially A and B, at these two numbers, and at the critical numbers. And since there's a lot of calculations going on, I very often do this as a table. So I'll start at negative 4, 0, 6, and I finish at 8. And I'm going to evaluate the original function, this guy, at these 4 fellas. And it's sometimes worth it to do it this way. Use table of values. So I'm going to go second, I'm going to do y equals first. Clear that guy out. And what's it going to be? X cubed. Subtract 9x squared. Add 7. And you only need to do this next step once. Go second table setup. Make sure that the independent is highlighted as ask. Right? Just make sure that is at ask. If you've done it once, you can leave it alone. You don't need to go and do that. And lastly, go to second table. And then I just type in the number negative 4. And the answer I get is negative 201. Then 0. And the answer I got for that is 7. 6. The answer I got for that is negative 101. And 8. And the answer I got for that is negative 57. Do you see how quick that was if you let the table of values, do the heavy lifting? Right. So I've evaluated this function at the 2 endpoints and at all critical numbers. So that's step 3. Step 4. The absolute max is this one. The biggest number out of the four is the absolute maximum. And this fella here, he is the absolute minimum. And there you're finished. Now, if you're wondering, how does this technique actually work? Why does it work, if you want to think of it like that? Well, can you imagine you've got a function that starts at some guy A, we'll make it here, right? And it goes up, and it goes down, and then it goes up again, and I'll make it come back down, and I'll make it come back down, say it there, right? The absolute max and min of these functions, well, isn't that where the absolute max is? And isn't this fella the absolute min, right? What's special about those guys? Well, isn't the absolute min one of the two endpoints? And isn't that guy one of the places where the derivative is 0? So can you see that the absolute max either lives at a critical number, right, a 0 derivative, or it happens at one of the two endpoints? And you might say, well, why undefined? Why do we need that? And do you know you can have functions that look like this? This guy here, right, is the absolute min. Isn't this guy here the absolute max? What's the derivative at one of these funny corners? Isn't it undefined? So that's why that is there. And that's called a cusp. So if you ever hear me calling something a cusp, it's when you get one of these funny little corners. Now, a lot of people like this process because it's a process. You do step 1, 2, 3, and 4. And if you follow the processes properly, you always get an answer. So let's find somebody else. Boring, don't like those. Yeah, this one looks interesting. F of t equals t squared take away 9 cubed. And we're being asked to find the absolute max and min in the range -3 to 5. So I'll differentiate. What method will I use to differentiate this function?
Chain rule.
Right, it's a something cubed, a chain rule. So something cubed, 3 something squared times the derivative of that something. Tidy it up a little bit. I don't think I had too much in the way of style points. Would you agree this one looks pretty much ready to go? So let's look for critical numbers then. When is this equal to 0? Well, when t equals 0. Be careful about the second one. When is t squared minus 9 equal to 0?
Plus or minus 3.
Yeah. Do you know the mistake some people make? They forget the -3 one. They only recognize that t equals 3 works. Now, I should do a check. Are all these critical numbers usable? Are they in the interval -3 to 5? Yep. Step 3, set up our table. And we're going to evaluate it at starting at -3, then going 0, going 3, and finishing at 5. And the reason why I only have 4 numbers instead of 5 is, isn't this -3 also an endpoint? So you don't do it twice. I could plug that in, but this one's easier to do. And that's 0, that's 81, that's 0, 256. So
Wait, why is 081? Wouldn't that be 9 cubed or negative 9 cubed? Or
I can't do it. I 9 squared, didn't I?
yeah, it would be negative
Well,
9
well
cubed.
caught. That I can't do in my head easily. So 729. And this guy is going to be 25, 16 cubed. For some reason, I was squaring. There we go. Right. So, okay. Absolute max. $4,096. Absolute min. It doesn't matter if the absolute minimum happens in 2 places, isn't it still 0? It just happens to be 0 at 2 places. That's okay. I guess the moral of that story was be careful when you do things in your head. Are we good with that one?
Wouldn't it also be negative 729 since it's negative 9 cubed?
Which one?
For the 0, wouldn't it be negative 729 because it's negative 9 cubed?
Ah,
So that would be the absolute minimum.
yeah, so it's now the absolute minimum. Moral of that story, Donald, don't do anything in your head, right? Just don't do it in your head. Just plug it into the calculator and trust it. I think I still haven't learned that lesson. I guess I'm too much in a hurry for my own good. I'm looking at them, but there's an awful lot of just polynomials. Oh, good. Here's one that's not a polynomial then. But it doesn't have an absolute max and min to it. So I guess, do I have a absolute max and min that's not a polynomial? I've got this one. And we're going to do it in the interval 0.2 to 16. Well, if I differentiate this guy, remember to turn into that, but if I differentiate this guy, you get 1. And if you differentiate this guy, you get that. Right? Multiply by the power, reduce it by 1. If I try and make this look pretty, I get that. Can't really do much else, so I guess that's me finished with the style points. Let's go looking for critical numbers. Well, let's solve this one. When is it equal to 0? Okay, start the ball rolling. What could I do to both sides to get this closer to being solved?
Add 16 over x squared.
Okay. Would it be okay to just jump straight into that? Are you happy with that? Basically multiplying both sides by x squared. Are you also happy then that the answer is plus or minus 4? Agreed? Which means that our critical numbers are allegedly, so far, these two. Let's add to the list. Is there any value of x where this derivative is undefined?
0.
0. Now, these are candidates to be used, but now let's see which ones we can use. Is negative 4 in this range? Nope, can't use you. Is 4 in this range? Yeah, I can use you. Is 0 in this range? No. Did you see in this case, 2 of the critical numbers are not in the range 0.2 to 16? Right? That one's a bit short, that one's a lot short. So I'll set up my function and the x guys, and I'm going to break my rule I am going to do this in my head. So that should be fun, right, guys? So the function is x plus 16 over x, right? If you plug in 0.2, that's 160 over 2, which is 80, and 80.2. And if you plug in 4, you get 4 there, and 1, 4 there, you get 4 and 4, you get 8. And if you plug in 16, you get 17. How does that look, guys?
What about 0?
0 was kicked out because it is not in the range 0.2 to 16, so I can't use it.
Oh, yeah, okay, that
Yeah,
makes sense.
yeah,
I'm
and
done.
I kicked out the -4 for that same reason. Well, absolute max, 80.2. Ooh, almost put it in the wrong place. Absolute min, 8. So for this function, if you're only interested in x's between 0.2 and 16, the biggest answer it ever gets to is 80.2, and the smallest answer it ever gets to is 8. Can you imagine these functions represented things that you're interested in, the temperature or something, or the speed of something, the velocity of something, or whatever it might be? Aren't you quite interested in the absolute max and min in a certain range? Right, what's the biggest this is ever? What's the hottest it's ever going to get? What's the coldest it's ever going to get? What's the fastest and slowest it's ever going to be? You know, those kind of things. What's the biggest stress it's going to be under? What's the least amount of stress it's going to be under? So can you see absolute max and min could be quite helpful for any formula if you're interested in what it was doing in a certain range. Useful thing to know. Any questions so far? That one went pretty smoothly. Okay, they seem to like polynomials, so to heck with it, I'll do a polynomial next. They're kind of easy, but that doesn't mean we shouldn't do them. So which one am I doing? Oh, I'm staring at 18, so I'll do 18. We're finding the absolute max and min of 6x to the 4, take away 8x cubed, take away 42x squared, plus 1, and we're only interested in the range of x's between -2 and 3. So the derivative is just a power rule. 24x cubed, take away 24x squared, take away 48x. Okay, go for style points. Looks like we should be able to factor it a little bit at least. What can I use as a common factor?
24x.
So I would just, that leaves me with an x squared, take away an x, take away a 2. Okay, have a look at the quadratic. Do you think we can factor that guy? Math 94, 99. It's came back to haunt you guys. Right? It can factor. What are the two numbers that work?
+1 -2.
Okay, would you agree we factored the heck out of this? So we're pretty much style points finished. Okay. Let's look for critical numbers now. Okay, when is this going to be 0? Would you agree at x equals 0? At x equals -1 and at x equals 2. Are any of these guys not usable because they aren't in this interval? Are these guys okay? 0, -1, and 2. They all okay? Okay. So, question? Okay. So, I'm definitely not doing this in my head. going to start at -2, then I'm going to have a -1, then a 0, then a 2, and I'll finish with the endpoint of a 3. And remember to use that guy. And into my calculator, because it's already pretty much set up to do this, 6x to the power of 4, take away 8x to the power of 3, take away 24x squared, and add a 1. Since I've already done the table setup, I'll just go second table, and I put in the numbers -2, -1, 0, 2, and 3, and the answers I get are 65, -9, 1, -63, and finally 55. Have I sold you on table of values can be very helpful in step 3. So absolute max. Biggest number I can see is that one. So the absolute max is 65. And would you agree that's the coldest number? So that's the absolute minimum because it's the smallest. And there is step 4. So we have a step 1, 2, 3, and 4. Differentiate, make it look pretty with style points. Step 2, get all the critical numbers. Step 3, table of values. Step 4, biggest one is your absolute max, smallest one's your absolute min. Do you have any questions, or do you feel comfortable about these guys? Okay. Things to watch out for. Well, you've already seen me screw up. Be careful when you do your tables. But if you let the calculator do it, I guess that's not going to be a problem, right? Because calculators don't make mistakes like humans do. Make sure that you only use critical numbers in that interval, because sometimes people forget to do that check and they use a number that's not in the interval, and therefore they get a table value that they shouldn't be using and get the wrong answer. And I guess the last thing is style points. Make it look pretty, right? Factor the heck out of it. Make it look like the original, right? Because if you can do that, won't step 2 be a lot easier? Because finding when the derivative is 0 or undefined is much easier to do when it looks pretty, right? When the derivative has its style points thing going. Okay, say hi and bye-bye.